Okay, so we will get started with logistic regression today. Um, and as you know, linear regression uses a straight line to to draw a decision boundary, to separate two different classes, right? Or actually, linear regression uses linear line to calculate the least possible distance between the data points and the best fit line, and thereby calculating the continuous values. So, right? But imagine doing all the same steps of linear regression, and finally to the end result you pass that equation to a logistic function. Okay, so that will give you the differences between two classes. So we will see how things work, but even before we talk about logistic regression, so let's look at the sigmoid function. So sigmoid function, it's also called as expit or inverse function of logit. Okay, now logit is nothing but natural logarithm you are applying. Okay, so if you can see, this is the equation, this is what it looks like. If you want to find out the logit of certain value, so you can take the log of natural logarithm of p divided by 1 minus p. Okay, so here p represents the probability. Let's just say if you want to find out the probability of today raining. Okay, so what is the probability for a week? Okay, let's just say you want to find the probability of raining for a week. So how many days did it rain divided by how many days it did not rain. Okay, that is 1 minus p. So that natural logarithm you will take if you want to understand the probability. Okay, so this is the logit function. What you are seeing here is logit. Inverse of this logit will give you something called as exponential or sigmoid function. So mathematically it's very simple. You take 1 divided by 1 plus exponential of x. Here x is nothing but your entire equation. Y is equal to, you have m1 x1 plus m2 x2 plus m3 x3, okay, plus up to etc. up to mn xn. So here the value of x, although we're using x, but the entire value, ideally they use z, but this entire equation becomes your x value here. And in this equation m1 x1, m is nothing but the slope, okay, and x is nothing but the actual values of the matrices, that is all your columns. If you are taking a pandas data frame, all the columns, okay, will become x1, or actually one column will become x1, second column will become x2, third column will become x3, etc. So if you have n columns, xn will become all the columns. Okay, and m1 is what we have to find out. m1, m2, m3, etc. is, those are the values what we find out. So once you find out all those values in your training phase, you are going to equate it in place of this x, and thereby you will get the sigmoid function. For our example, let's to understand this better in practicals, let's do one thing. Let's draw a line. I'm taking a numpy array here. Okay, numpy array has dot points from 1 to 9. Okay, I'm only providing the values, single scalar values here. That means to draw a point, to draw a line, you need a from point and a to point. From point is assumed to be a origin. Okay, so when I say 1 2 3 4 5 6 7 8, you understand that it is going from 0 to the starting point is 0. Okay, that way you understand. Anyway, when you plot this, you take this line, you plot this x, you will get something like this. See, goes from 0 up until the 9th point here. Okay, x value is at 0, y value is at 1, x value is at 1, y value is at 2. So that way starts at 0 on the x axis, but on the y axis it's starting at 1. So you will get a straight line. Okay, So you take this, you draw a straight line. But if I equate that straight line here in this value in place of this, okay, so this entire x is being replaced here, put in here, and I'm returning 1 by 1 plus numpy of that is exponential of this equation, which is what I'm getting here, sigmoid function. And notice the values I have printed. 1 has become 0.73, 2 has become 0.88, 3 has become 0.95. So this way it has gone up to 0.99. Okay, 9 has become 0.99 from this equation calculation. But if I plot it, that is where things get interesting. The straight line is getting curved. So essentially your sigmoid function has the ability to take a straight line and curve it. And notice the y values. Y values are going from, they are less than 1. Earlier y values were up to 9, 1 to 9. Now they have been reduced to 1. The upper limit has been set to 1. Lower limit we will talk about the lower limit. What could be the lower limit? But for now here you can understand 0.5 is the lower limit. Okay. Now I'm taking this experiment a little further. Instead of taking only values, positive values, now I'm also going to take all these negative values, and I'm equating in an equation called y is equal to 2x plus 5, right? So you must have seen these equations in your 12th standard, where you must have solved, where you have taken two linear equations and solved for x or y, right? So I'm taking the same equation, just changing the values of x to get the values of y, okay, and these are the different values of y I am getting. But interestingly, if I go ahead and plot this, okay, don't worry about the fancy coding here. I have just added the three-dimensional I have used Plotly to get the three-dimensional plot, okay, interactive plot, not three-dimensional, interactive plot. So all I'm trying to do is I'm just calculating the equation. In the equation I'm substituting the same values. Notice the equation is the same. This is the c value. I'm multiplying with 2 and I'm passing it for different values of ax, and I'm calculating the sigmoid y. So when I do that, notice this equation straight line that was there now got curved in the S form. Okay, so essentially what we have to understand here is sigmoid function can take any set of values and make it into a S-shaped curve. You can pass any values here. You not only straight line, you can pass even quadratic line. It will still try to curve in the sigmoid form only. But the challenge is to that quadratic thing you have to transform first. Okay, transform and then pass to sigmoid. It will still make into a S shape. Okay, so basically sigmoid function I'm reiterating, sigmoid function can calculate y values. Here we are trying to calculate y values, right? We are taking y values, okay, passing it into sigmoid function and getting a curve out of it. Now what does this curve, why do we need this curve is the question. What is this curve? Why is this curve important for us? Very simple. In the curve, the upper values that you see, so basically any value that is coming up upper side, okay, so anything above this 0.5, okay, will be part of one class, and any value that comes below this 0.5 will be part of another class. Okay, so the values that come above could be, let's just say a person getting a loan. Let's just say we want to give a loan to certain people, and we pass all their x values, calculate slopes, and then use slopes and then multiply with x values to get the y value. Okay, and that finally y value are being passed in the sigmoid function, and this sigmoid function can compress those y values between 0 and 1, and wherever the value lies in this curve, Okay, if it lies on the upper hand, we will give them loan. If it lies on the lower hand, we will reject their loans. Okay, this is how the logistic regression works. So did you follow what we just went through? You okay? Good. Now we will see how exactly logistic regression is doing this. Okay, before that, logistic regression, okay, will and ultimately see, talking about the sigmoid function, in the sigmoid function, okay, when I printed the values, notice you got the certain values in floating points, but you actually passed 1 2 3 4 5 6 7 8 9. You passed the actual integers, you got the float values. You're not getting certain thing belongs to certain class or certain integer values. You're not getting. So this is again one of the interview questions. What is the outcome of logistic regression? Whether it's a probability or whether it's a class, usually people, what will they say is, logistic regression will directly give you the class, because that's what logistic regression is used for. But that is not the case. Logistic regression will only give you the probability of something belonging to certain class. Now how much threshold, you have to apply a threshold. In this case we are applying the threshold as 0.5. We are saying anything above 0.5 will be loan approval, anything below 0.5 is loan rejection. Now let's just say bank wants to give loan to less number of people. Only the people, bank wants to be very sure that only people who can repay will get the loan. Then you will increase this threshold. To decrease the number of people getting the loan, you have to increase the threshold. If I make the threshold as 0.8, only 20% of the people will get the loan. If I want to, now let's just say the bank got a lot of cash. Now they are willing to trust even the people who have with less CIBIL score. Now they have to decrease this threshold to 0.3 or some other value, so that majority can get the loan. Okay, this way you can modify this threshold value to suit your requirements. Okay, just remember that much. This threshold value plays an important role. So we will come to the false positive and false negative recall precision, all of that, because that is where this threshold is required. Okay, this threshold plays a role there. Anyway, just remember that much. Next, the logistic regression will give you the probability only. Okay, it is the threshold that gives you the binary outcome. Okay, basis on the threshold value, you will classify people into two different classes. Okay, these are just the other names of logistic regression. It is also called as logit regression, because clearly you're using natural logarithms. Okay, inverse of natural logarithms to get the sigmoid function values. So it is also called as maximum entropy. Okay, maximum entropy calculation. Okay, and we'll come to that why it is called like that later on. Okay, entropy, just understand its randomness, maximum randomness. Okay, I'll explain you this later. Or it's also called as log linear, and there are certain variations of this linear regression. Okay, first it can be applied for binary classification, or it can also be applied for multinomial classification. Means if you have multiple class values, like instead of classifying people into loan approval and loan rejection categories, you're gonna apply change the use case into basis on the amount. So let's just say certain person getting certain probability will get highest amount loan amount, and second category would get a medium amount loan, third category will get least amount loan. So that way also you can classify. Basically from two classes you are going to multiple classes. So that is what logistic regression can be used for. Okay, we will see how that can be done. And again, it also uses regularization to reduce overfitting, just like your linear regression. So all those things that apply to linear regression also apply to logistic regression. Okay, now here first you have to understand is mainly it is used for binary classification, but certainly it can be modified to get multinomial classification. And second feature you have to understand is sigmoid function. This sigmoid function plays the role along with the threshold. If you combine sigmoid function and the threshold, then you are taking a straight line, bending it, okay, converting it into a shape, and whatever values are above the threshold will be one class and the other values will be in the another class. So this is using the same equation. This is a straight line equation, right? Y is equal to m1 x1 plus m2 x2. This y value is z here, m or beta, they are one and the same. Okay, so this is the standard form of the equation. Next is it gives you the probability as the output, okay, and to that output you can apply the threshold to make the predictions. Okay, and next is it will give you the log odds. This we will talk about in depth. Okay, but for now just understand it gives you odds and log odds. Okay, what they are and all of that I'll explain, okay, in a bit. Now how does it work step by step? Okay, most of the steps are common to linear regression. How does it work? In steps we have to understand. Again, we have to understand this in two steps. Okay, first step is always training step. In training what is happening and in testing what is happening, that we have to understand. So in training, see, first step is you will split the data set. 80% of the data you will take as training data set. Okay, 20% of the data set you will take it as testing data set. Okay, now in 80% of the data that you have taken, so what you have to do is for this 80% of the data, see in the equation y is equal to mx plus c, you already know y are nothing but whether it is 1 or 0, right? So if let's just say this. Okay, so I have read I will talk about this here. Okay, so when you print this data set, right, data frame, all these are x values, all up until this point are x values. Date you leave it, date we don't consider, but all other values are x values like location, minimum temperature, evaporation, pressure, humidity, etc. Up until this point are x values. So x is essentially a matrix. Okay, so let's just say in this equation x is a matrix that is known. Okay, y value is rain tomorrow. We want to find out whether it will rain or not. So either they are yes and no values or they are 0 and 1 values. Okay, so initially in the training phase you already know the y values, whether it will rain or not. You already know x values, which is your entire data frame. X values matlab you already know x1, x2, x3, x4. Okay, this one, each column is x1. So this is x1, this is x2, this is x3, x4, x5, x6, x7, x8. So this way this consists of how many? 23 columns you have. Out of those 23, one you leave it, one should be y. Okay, 22 remaining, you out of 22 you leave the date, we don't consider the date. Okay, 21 are x values here. So that means your equation now is y is equal to, which is rain tomorrow, equals to m1 into location plus m2 into minimum temperature plus m3 into max temperature plus m4 into rainfall. This way the equation will go. It's a multi-variable, that's why we call it as multi-linear regression, multiple linear regression, because there are multiple columns. Now in this training phase you already have this you already have this x here is nothing but x1 plus x2 plus x3 plus x4. Essentially this equation have to be rewritten like this: m1 x1 plus m2 x2 plus up to etc m21 into x21 plus c value you leave it, it's a very minor value, we will come to that. Okay, ignore the c part for now, I will come back to it. So this is your equation for initially in the training phase. When you do that splitting, this is what the data looks like. Okay, next, we don't know m1, m2, m3, m4 up to m21, those values we don't know. Okay, initially we don't know. So what you will do is you will randomly initialize. Okay, so you will randomly initialize into small values, or there are different ways, different heuristics, means different algorithms can be used to initialize those. For example, greedy algorithms. Okay, stochastic algorithm, sorry, stochastic algorithms, either gradient descent based stochastic algorithms can be used in different ways. You can initialize the values for these parameters, but let's just say randomly we'll take the values of m1, m2, m3, etc. we'll randomly take, and we will start multiplying those with x values we already know, x1, x2, etc. we already know, and you will assume certain values of m1, m2, m3, and you will equate it with y. Now when you do that, they will not be equal. They will not be equal, right? Because these values are assumed values. You don't know. Okay, you have to find out. So they will not be equal. Now here is where the confusion happens often to a lot of folks. There are two different ways how you can find out. One is called as ordinary least squares. Okay, this first method is something called as ordinary least squares. Second method is called as gradient descent, and there are a few more also. Okay, crescent descent. Okay, another one, crescent descent. So different ways are there to find out the values of m1. I will talk about one by one. Linear regression uses OLS. Okay, linear regression uses OLS, means ordinary least squares. What you will do is, in this equation you have to find out m1, m2, etc. up to m21 values. What you will do is, in OLS, you will not randomly initialize m1, m2. Instead, you will flip the equation. You will try to get the exact values of m1 or the approximate values of m1 by changing the equation. For simplicity, I will talk about mx, y is equal to mx plus c I will ignore. Okay, so in this equation, if you want to find out m, so you can't see, ideally what you would do, y divided by x is equal to m is what you will do, right? If you want to solve for m, you will take y divided by x and you will get the m value. That is in the normal division. But in matrices you can't divide. There is no concept of division. Instead, what you can do is you can take the inverse of x. Okay, so the way how you would do is, I will write inverse of x as like this. Okay, okay, so what I will do is, inverse of x is nothing but one more step before this to avoid the confusion. In normal mathematics, in the normal division, you can do either y by x equals to m, or you can divide and multiply by x. Y divided by x, okay, into x, sorry, okay, let me write like this, m is equal to, or you can write this equation as mx equals to y, or you can write like this, m x multiply by x and divide by x on both sides. Mx divided by x equals to y divided by x. So basically I am dividing the equation on both sides by x. So this way I can get rid of x divided by x on one side. Here I'll get y by x. Both are one and the same only. So if you see to the first equation what I wrote, this will be 1. X divided by x is 1. So essentially it is m equals to y by x only. Okay. Now the same way, instead of divided by x, what I will do is I will multiply by inverse of x. Okay. Here also I will do the same thing. X is there, I will multiply by inverse of x on both sides. So this way you can get rid of x into x inverse on one side. You will get only m. Here you will get y into inverse of x. So this equation will become, in the next step, this equation will become this. Okay. So essentially to get m in the training state of linear regression. Now I'm not talking about logistic regression. You have to understand linear regression first to understand logistic regression. So first way of doing things is, in ordinary least squares, you will calculate inverse of x. Once you calculate inverse of x, if you multiply by y, you will get m values. Okay. Once you get this m1, m2, and you will do this for all the columns. Once you get this m1, m2, m3 up to m21 values, okay, in the training state, you found out m. Now in the testing step, in the testing value, what you will do, you already know the m values, okay, and you will be given the x values. X values are the testing values, these values only from the test data set you will get. And in the test data set, you won't have rain tomorrow. That is what you have to predict. How you will predict is by multiplying this calculated m values into x. This will give you y cap. Okay. This will give you predict y pred, or you call it y pred better. Okay. So this x is your x test. Okay. This x here is x train. Here it is x train. Okay. This was y train. Okay. This was y train. In order to equate y train, you equated with m values into x train, and you calculated the m values. You are taking that m values again, you are multiplying with to x test, and you got the y prediction. This is how ordinary least square works to get the y prediction value. Now after you got the y prediction value, what you will do is you will try to subtract y from y pred. Okay. Either, now it depends on the loss function you have considered. Either you can take the absolute value. Okay. This is loss function. Or you can square it. Okay. This becomes, if you square it, it becomes mean squared error. If you take absolute value, it becomes mean absolute error. If you take a square root of it, okay, np.sqrt, if you take of this entire thing, now it becomes root mean squared error. It depends on you how you want to take the difference of these two. For simplicity, let's take only the absolute difference, only this difference, highlighted section, y minus y pred. Now you know the difference is too much. If the difference is too much, okay, what you will do is you will go back and slightly change the value of m. Now how you will do that? How you will do that is by incorporating another. Basically loss function is calculated. Here is another feature of OLS. Loss function is calculated for every row. Okay. For every row you calculate this. Cost function you will take the average of all the losses of all the rows. Okay. All losses divided by number of rows. So this will give you the average. Okay. Average of all the losses is nothing but your cost function. Okay, so this way you will get the calculation in ordinary least squares. Okay, and these ypred could not may not be perfect because it all depends on the inverse function calculation. It will be very close to what it is supposed to be because you're doing the proper calculation here. You're not predicting but rather actually calculating inverse. It all depends on this inverse calculation. If you get this inverse calculation of x correctly, then y value, m value will be correct. If m value is correct, you'll substitute, your y pred will be correct. So this is OLS. What I explained now is for linear regression, OLS, ordinary least squares. Okay, now gradient descent means in the same process for linear regression. See, normal linear regression uses OLS only. But if you modify that linear regression to use something like polynomial regression, ridge regression, lasso regression, or Huber regression, Ransack regression, okay, there was another one called Thiel, right? So that regression, whatever the regression use, you can either use or even stochastic gradient descent. Stochastic, there is GD regressor, gradient descent regressor, SGD we call it, right? SGD regressor. It's called as SGD regressor. So if you consider these type of regressors, these are the variations of linear regression only. The slight modification to this entire process is you will not calculate the inverse function. Okay, in SGD, okay, let me put it here maybe. Understanding this is very important so that you can, again, if you understand this now, okay, what will happen is for neural networks, it will be like piece of cake for you, because the same process happens there also with additional one extra step called back propagation. Anyway, we will talk about that later in that section, but here for you, okay, in stochastic gradient descent, what happens is again crescent descent I will explain later. Okay, in gradient descent what happens is very slight modification to this process is first step will remain same. You will split the data into training set and test set. Okay, equation also remains the same because you have 21 features only. Okay, here this part also remains the same. Basically you have to find out m value, but what you will do is for m you will randomly initialize values for m. So basically you will assume certain values for m and you will put it in this equation. If you put it in this equation, if you multiply in this equation, you will get certain ypred value. Note here what is happening is m is randomly initialized. Okay, some random value gets multiplied to x train value. X train is again all these features. Okay, y train you already know, which is your ones and zeros. Okay, but when you equate this, you're going to get certain result, right? When you do this random value multiplication, here you are essentially not okay, let me get this will be ypred. Okay, what you are trying to do is you're directly not multiplying, you're directly not using y train in the equation. You're rather what you're saying is I will take random values of m, multiply it with x, okay, all these values, and see if they match with these. So basically you're doing trial and error method now. Okay, if the values are not equal to these, if they are far away from these values, okay, what I will do is I will slightly adjust this random value. Either I will decrease it or increase it. Okay, usually it is the process of decreasing, but sometimes you can increase also. You will modify these values. Okay, and resubstitute these values in to get y pred. After you get y pred, you will take y train minus y pred, y prediction. If that value is okay small, basically you don't care whether it is small or large initially. Okay, large or small doesn't matter initially. What you will do is you will keep on modifying this m value, decreasing it, and keep on getting this value up until, this is the interesting thing, up until you start noticing that the difference is no longer changing. Okay, if this difference is not either decreasing or not either increasing, up until this point you will get, for example, let's just say, so you have been calculating this process for 10 times, and in the last 4 times you got the value as very small, 0.001. So let's just say you got a very small value and it is not changing also. Now what you have understood is, okay, I can further decrease my, this is loss function, right? This is absolute value we are taking. So I can no longer decrease my loss function. Okay, so if that is the case, then the m value that I have randomly initialized, that is my best m value. Okay, so now you know you calculated the m value basis on guessing and doing trial and error method, and you are going to now use that m value that you have obtained from training, okay, to multiply with x test data frame to get the actual y prediction value, whatever the new value, y cap value or y prediction value. Okay, so this is the process, okay, of getting the, let me say y new value to avoid the confusion. Okay, so this way you will do the gradient descent part. Did you follow this process, gradient descent? Okay, all right. Now here is the catch. In this all this process, there is one doubt here. The doubt is very simple. Okay, you randomly initialize the value, which is fine in the first step, but in the second step, how did you know whether to increase the increase this value by first of all increase this value or decrease the value? That is question number 1. Okay, doubt. First question is how to know whether to increase or decrease the randomly initialized value. That is question number 1. Second thing is, let's just say you got to know whether you have to increase or decrease. Next question is, by how much will you decrease? How much will you increase or decrease? Okay, and how many times we increase or decrease we already discussed. We'll continue doing that until we no longer see the difference. That answer the question, that question is answered. But these are the, but anyway I will type that question. So when to know when to stop, how to know when to stop, basically how to know when to stop increasing or decreasing that m value, increasing or decreasing m value. So these are some of the questions that arise in this gradient descent process. To answer these questions, randomly initialized. Okay, and there is one more, sorry, there is one more question. So when you randomly initialize, I can initialize a million also, right? I can that is also random value, but how will you know what range of values should be random? What range of values should be initialized? So that is another question. Okay, take this as first question. Second is how to know whether to increase or decrease. Third is how much, third is when to stop, increasing or decreasing m value. Now this is where this point comes. Small random values have to be initialized. What range of values? This is answered by heuristics. Okay, heuristics are nothing but algorithm. Heuristics are algorithm. Generally, one of the example, best known example is greedy algorithm. Okay, greedy algorithm. Using this algorithm, you can make sure that the values that are initialized are always small. Okay, so only small minor change you will do, so that you will get the y value you're trying to get. Okay, so this is where this point comes. Model initialization point comes here. Okay, so in this equation, random value, how much to initialize, that is taken care by certain other algorithms like greedy algorithms. Next is you're going to calculate this, which is what is the third step in linear combination for the logistic regression. Okay, now we are talking about both linear as well as logistic regression. Okay, combined, because both follow 90% of the steps for both are same. Okay, so this is the third step in the logistic regression. In logistic regression, you have to find out y value. See, this equation is same as y is equal to theta is m. Okay, theta is m. So don't get confused between the representation. Both are one and the same. Z is equal to x into theta is same as y is equal to m into x. Okay, y value is z and theta value is m value. Okay, so third step here is you will multiply after initializing randomly. How you will initialize? You leave it to greedy algorithm, that I will explain how that works. Okay, once you get the random values, you will multiply in this equation. You will get the y values, which is same as y train values. Okay, equating to y train values. Okay, next, after you get this y pred, you calculated, you understood the y pred value. Okay, after you get the y pred, okay, this is where the similarity end. For linear regression, you will get y new value. Okay, y new value is something like 0.756 something, it will be there. Okay, but this is for linear regression, you will get the floating value. But for logistic regression, what you will do is you will pass this value in logistic function. You will take this value, you will pass in sigmoid function, and we already saw what sigmoid function does. You pass any value to it, it will compress between 0 and 1. That we already know. Okay, so for logistic regression, you will take final value that you are getting, you will put it in logistic function. Okay, and that gets equated in this equation. Here z value is the entire equation. Z value is here in this equation. Z value is nothing but your slopes multiplied by this equation. This entire thing is z now. M value you found out, okay, from training. X values you already had. The combination of that you will substitute in that sigmoid function. Finally, once you do, you will start noticing, you will get this sigmoid value, sigmoid transformation, along with the probability values. Notice at 9 you are seeing the probability as 0.993307. At 8 you are seeing the probability as 0.9525741, etc. So this way you will get the probabilities, and those probabilities you will set a threshold. Any value above this probability will determine a value belonging to one class and the value belonging to another class. Okay, so once you will get the z value, so your entire equation you will pass to sigmoid, and then you will get the probability. That probability is determined, either it will be 1 probability or it will be 0, and that depends on the threshold value. Okay, you will set the threshold value, and once you do, okay, don't worry about this log likelihood function. This is for logistic regression. This another slight difference is you don't directly subtract y train minus y pred. Instead, your loss function will become this y log into sigma. Because you're using sigmoid function, you will have to calculate the loss function like this, yi into log of sigma of zi. Okay, this will become your log function, loss function. Okay, you no longer are using the straightforward mean squared error or mean absolute error, okay, like I showed here. Instead, you are substituting all these values in this to get the loss at each row. For each row, after you do the transformation, okay, you will see how much loss you are getting. Okay, and basis on that, you will go back to the original equation. You will see if the difference is too high. Okay, you will go back and substitute in this equation. You are again doing the gradient calculation. In gradient calculation, what you are doing is, actually I don't think this equation is correct here, but anyway, I will resubstitute. What you are going to do is, you are slightly decreasing by multiplying the learning parameter. You will take a learning parameter, slightly reduce the values of m, okay, in order to adjust the y values which are already initialized by a greedy algorithm. Okay, so that way you will calculate the gradient, and finally you have the origin. Don't worry about this complex equation. Finally you will have the predictions which are closer to the original values. Okay, so this is how logistic regression works. In logistic regression, the main thing you have to understand is, m values are randomly initialized by a greedy algorithm. Then you will calculate, substitute those m values into a final equation, and you will slightly adjust the m value calculation. But before that, you will substitute that whatever the values you have obtained in the sigmoid function, and basis on that you will calculate the loss. And for that loss log likelihood, we call here, we no longer call it as loss function, but rather we call it as log likelihood function. Okay, because there is a usage of log here. Anyway, so once you do this, you will get the m values. Sorry, once you do this, you will get the error rate, how much error it is there, and slightly basis on that, you will go on to modify these m values again by subtracting a small value of learning parameter. Okay, this way you will adjust, and you will keep repeating this process until this entire function no longer changes. So this way the values start getting constant. Once you do, you already know you have the best m, and you take the m, multiply with x test, you get the new prediction. And this prediction also is not the exact prediction. You have to again pass it to logistic function to get the final. Basis on the threshold, you can classify them into certain classes. Is this understood or still confusing? Okay, all right. So one slight example, simple example we'll see here. Okay, so in yes, you can import logistic function from sklearn, and okay, so I'm taking only one feature here, which is study hours. We are trying to determine who will get passed basis on the number of hours they have studied. Okay, so here x becomes study hours, y becomes just the y value, which is an array. Okay, so when you do a splitting, I'm just taking 80% of the data for training, 20% for test set, and when you fit the model here, lot of things are happening here simultaneously. Solver is being used. Solver is the optimization algorithm which will make use of that learning parameter. It will make use of various things, and we'll discuss about this. Okay, basically it will use multiple different ways to calculate the m values. Okay, so that is what solver is for, optimization algorithm. Next is, you have c value, you have penalty, what type of penalty you are going to impose, which is your ridge regression or lasso regression, and L1 ratio is not needed here, so it's none. and how many iterations. By default 100 times it will try to calculate. Okay, and because it's a binary problem, you have to set multi-class as none are deprecated. But for usually, if you have multiple classes, then you will set it as OVR, one versus rest, or you will set it as here. You will set it as OVR, or you will set it as multinomial. Okay. There are now the interesting thing is the solver itself. Rest are all very simple things that we can understand. Okay, but solver itself is very interesting. The solver is okay. I'll come to solver. But okay, those are the things that are happening in logistic regression. The moment you fit, what you are fitting, you're fitting x train and y train. Okay, x train is the in this equation. This is x train, sorry, this is x train, this is y train, this is what is your fitting. When the moment you start fitting, no, all these steps start happening up until this training part. Everything starts happening under the nose, and it will happen everything within a second. Because the rows are less, it will happen within a second. And the moment you predict, okay, the moment you do the prediction, all these steps will happen. This one, whatever the m value it has calculated, it will take, retain, and start multiplying to get the y pred values here. Okay, everything happens within a second. Anyway, so basis on that you can calculate the error. When you do this accuracy, you're trying to measure how far away is this y predicted, newly predicted value from the test score, or at least what you're trying to measure is for how many rows, how many percentage of data is this value very close to y test. So that way you can get the okay, I'll use SNS. I'm not using SNS. Okay. Okay, so this way you can okay, this way you can get the various metrics, actual versus predicted, you can calculate. And this is just one of the different ways to measure how many values did you get correctly. So you can see, always look at the diagonals on the left side. From the left you should come to right on the along the diagonal. So these are your true values, the correctly guessed values. And along the diagonal from the right to left in this direction, these are the values that are incorrectly guessed by the model or incorrectly calculated by the model. So 0, 0 indicates that means the model has got all 100% correctly. Okay, that's why accuracy is 1.0, 100. Okay, so this way you can tell the model is working correctly. Okay, for multinomial, as you can see, you have to just give this multinomial. Now here I have taken 3 classes, 0, 1, 2. Okay, 3 classes I have taken for the same example. And as you can see here also, majority of the people have been classified in 0 class. That means along this diagonal, whatever you see are correctly classified. Along this diagonal, as you can see, there are a lot of zeros, as you can see here, here, and this value. Ignore the center part. This value, this diagonal, and this and this. So if you notice all are 0, that means the model has done wonderful job. Accuracy is 100%. Okay, up until this point, did you understand how logistic regression is calculating under the hood? Oh, any doubts? Okay, if there are no doubts, then we will see some of someone was speaking. Okay, if there are no doubts, then we will see what are the assumptions, when to use, when not to use is the thing we will see. But I think it's already 10. Have you had breakfast, guys? If not, we can take a quick break now.